Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about this beta-napthol ether or allyl ether. So you have to say what is the major product of this reaction, and 4 options are provided here and one of them is the right answer. So I request you student, first please pause the video, try by yourself, and whatever answer you get please try write in the comment box and don't hesitate whether your answer will be right or wrong. Don't worry, after some time you'll get the right answer with proper explanation. Now let's start. I believe you have tried by yourself, so here I shall give you the right answer. So first step is the heat, second step is K2CH3 acetone bromide, third step is the heat only. So what is the final product? Now if you look at this molecule is student actually allyl ether, phenolic allyl ether, and we know such compounds can undergo Claisen rearrangement. Okay, and in this case how the reaction happens? Actually Claisen rearrangement, so this is Claisen rearrangement is 3' sigmatropic reaction. How I can say here? So this is 1, 2, 3 and this is 1', 2', 3'. So 3, 3'. How this reaction happens? So you can say that this double bond will attack here, it will come here and it will go there. So in this way first step will happen and ultimately what it will produce? It will produce an intermediate. How the intermediate looks like? So see, the other benzene ring will remain unaffected, and here you will learn a very important concept. So this, now this is allyl system, this allyl double bond and this. Now here student, there is already one proton there and this proton will be shifted from here to here. So you can consider this part is actually ketoenol tautomerism and aromaticity is the driving force. So in this way it will produce this derivative. Phenol means in this case it is not phenol, it is a beta-napthol. This is called beta-napthol. Now this is alcohol, means aromatic alcohol. So here next step is K2CH3 acetone, and acetone is actually solvent to dissolve this reagents. Now and third is allyl bromide. So in the first step, in presence of base and acetone, what will happen? Then this OH will be deprotonated and it will produce this alkoxide, means phenoxide derivative, and subsequently this phenoxide will attack this allyl center via SN2 type reaction. We know that SN2 reaction on allyl system is favored because the conjugation of the double bond. Fine. So here it will produce, it will again produce an allyl ether. But here if you heat, then no further reaction will happen and this is the product. Now the question is, why the Claisen rearrangement did not occur here in spite of having one free ortho position? Because I was talking this position, means this is one ortho. Not only that, there is one another ortho, so here also one ortho is free. So why the reaction didn't happen? Means this allyl group didn't migrate here. And this is because one concept, partial fixation of double bond in naphthalene system. I shall come after some time. But before going to details, let's learn this thing in very briefly. That if you look at, this is actually beta substituted. If you give this electrophile and Lewis acid, electrophile will come this position, this peri position, and means this ortho position. Now if alpha substituted we take and provide electrophile, it will come this para position. Why? This is because here this double bond is pushed and it attacks this electrophile and it happens here. But here these will push here, it will come and these will react with this electrophile, so it will produce. So this is student happen. Why? Because you can see here I haven't disturbed the resonance stabilization of this benzene nucleus. So means if you do resonance involving this benzene nucleus, then the resonance stability of this benzene nucleus will be disturbed. So that's not a good thing. So what will happen? This side will not be involved. So because of resonance, you can see why this is actually beta-napthol derivative selective for this ortho, whereas this alpha-napthol derivative is selective for para, and this concept is called partial fixation of carbon-carbon double bond in naphthalene system. Now, so what is the answer of today's discussion? So first is shifting of allyl with respect to ortho, and second, so diallyl. So this is the option B is the answer. Okay. So now, if this question appear in your exam less than 30 seconds, how can you solve? In this case, 2 points you need to remember. 1, about Claisen rearrangement, and 2, partial fixation of double bond in naphthalene system. So first you can understand that in case of K2CH3 allyl bromide, only shifting will go to ortho position. 1 true. So ortho position there will be 1 allyl. In 4 cases that's true. And second, K2CO3 acetone allyl bromide, so phenol will be allylated. Fine. Third, if you heat also, then reaction will not happen because these ortho is blocked and these ortho is not accessible because of the partial fixation of double bond. And here para is also blocked, so reaction will not happen, and that's why first step will be this. Fine, 4 options are there. Second, this will be allyl. Only 1 option follows this strategy. Okay, so in this case I don't think student tricks matters, so you should go stepwise. Now in conclusion, what you have learned today, that partial fixation of double bond is observed in naphthalene system, and in this case this beta substituents results in 1,2 substitution, although alpha results in 1,4 substitution. I have shown in Claisen rearrangement mainly its results actually in ortho substitution. If ortho is blocked, then paramigration occur, means its preference towards the ortho one. And here β-Napthol allyl ether cannot undergo Claisen rearrangement if peri position is already blocked. I have shown the first one. This alkoxide naphthol can also act as nucleophile, and means in this case this alkoxide, or you may consider this naphthol oxide, whatever, phenoxide, naphthoxide, so that can act as nucleophile and participate in SN2 reaction with allyl halide. And this reaction is actually Williamson ether synthesis. And remember student, these allylic systems are highly activated for SN2 reaction, and bromide is a better leaving group. And why SN2? Because of the conjugation of the double bond. So this is the end of discussion. I believe this video may be useful. Please write your opinion in the comment box, and if you really consider my contents are worthy, then please help this channel to grow. So stay happy.